Today we are going to actually calculate probability. So here's our formula for calculating probability, and that is the number of outcomes for the event, or what you want to happen, over the total number of possible outcomes. So for example, when you flip a coin, let's say you're wondering what the chance that you flip heads is. There's one side of the coin that has a heads on it out of two possible sides of the coin. So there's a 1 out of 2 chance of flipping heads. Theoretical probability is what should happen in an event. So you should flip heads 1 out of every 2 flips. But as you know, when you flip a coin, that's not what actually happens. And that's what's called experimental probability, and we'll learn about that a little bit later. So calculating some theoretical probability, if we roll a die, as a reminder, there's 6 numbers on a die, the numbers 1 through 6. So of those, one of them is a 3 out of 6 total possibilities. So there's our fraction. Converting that to a decimal, 1 divided by 6 is 0.16 repeating. Converting that to a percent, when I multiply by 100, I would get 16.6 repeating percent. So we're going to have you practice those conversion skills again today. Part B, what's the chance that we get a prime number? A prime number is a number that's divisible by 1 and itself only. So 1 is not prime because it only has one factor or number that goes into it. 2 is prime because the only numbers that go into 2 are 1 and 2. 3 is prime because the only numbers that go into 3 are 1 and 3. 4 is not prime because 1, 2, and 4 go into 4. 5 is prime because only 1 and 5 go into 5. And 6 is not prime because 1, 2, 3, and 6 all go into 6. So the chances that we get a prime number when we roll a die, there's 3 prime numbers out of the 6 numbers on the die. Now 3 out of 6 can be simplified to 1/2. 1 divided by 2 gives us a 0.5 probability as a decimal. And when I multiply 0.5 by 100, or move that decimal 2 places to the right, I get a 50% chance of rolling a prime number. And my last probability, what's the chance that I roll a number greater than 4? Now this does not say it includes 4, it says greater than. So 5 and 6, or 2, out of the 6 numbers on the die are greater than 4. This fraction does simplify to 1/3, dividing them each by 2. 1 divided by 3 gives us a 0.3 repeating decimal. And when I multiply that by 100, I get 33.3 repeating percent. This next example, I will say, is my least favorite example of probability ever, because when do you put marbles in a bag and wonder what the chance is that you're going to pull out a certain color? So you'll see on the assignment I changed it to gumballs because that does make sense. However, we're going to go with marbles for now. And then a little bit of notation. So right here, what this is saying, that P is for probability, and then what's inside is what we're looking for the probability of. So when we look through, there's 6 red marbles, 8 blue, 2 yellow, and 9 white. Well, white starts with a W, so we're looking for what's the probability that we pull a white marble out of the bag. There are 9 white marbles, and then we have to figure out how many marbles there are altogether, the total number of possible outcomes. 6 plus 8 is 14, plus 2 is 16, plus 9 is 25. So there's a 9 out of 25 chance that we pull a white marble out of this bag. 9 out of 25 is simplified, so converting that to a decimal, 9 divided by 25 is 0.36. Converting that to a percent by multiplying by 100, or moving that decimal 2 places to the right, we get a 36% chance of pulling a white marble. Part B, what is the probability that we pull a marble that is a primary color? Well, the primary colors are red, yellow, and blue. So we have 6 red marbles, 8 blue marbles, which gives us 14, plus 2 yellow marbles. So we have 16 marbles that are a primary color out of the 25 total marbles in the bag. That is also in simplest form, and 16 divided by 25 gives us 0.64. And multiplying that by 100, or moving the decimal 2 places to the right, we get a 64% chance of pulling a primary color marble from the bag. All right, on this last one, I'm going to pause and insert some questions and then go over it to check for your understanding of theoretical probability so far. So looking at this spinner, we're looking for what's the probability that we spin a multiple of 3. So multiples of 3 are numbers that 3 goes into. So look at that spinner, figure out how many of those numbers 3 goes into, that's your numerator, and then how many total possibilities you have, and that's your denominator. On this spinner, we have 3, 6, and 9 that 3 goes into. So there are 3 numbers that are a multiple of 3. To figure our total number of possible outcomes, we need to be careful. The number 10 is on here. However, there are not 10 sections to the spinner because we started at the number 3. So there are 1, 2, 3, 4, 5, 6, 7, 8 sections to the spinner. So 8 possible outcomes. 3 divided by 8 gives us 0.375. Multiplying that by 100, we get 37.5%. All right, take a look at part B. What's the probability that we get a shade of orange? In my opinion, there's 2 slices that look orangish. These 2 right here. So 2 out of, still we had 8 possibilities. We can simplify 2 out of 8. Dividing them each by 2, we get 1/4. 1 divided by 4 gives us a 0.25 chance. And multiplying that by 100, 25% chance that we spin a section that's a shade of orange. Part C, we're looking for the chance that we get a section that is less than 5. So on this spinner, we have 2 numbers that are less than 5, which gives us the exact same value that we just got for part B, simplifying, dividing 1 by 4, and multiplying by 100 to get our percent. All right, hopefully theoretical probability makes some sense to you. Today we're looking at just kind of setting up some basic probability. Tomorrow it will get a little bit more complicated. Talk to you later.